Good evening to everyone. This is Dr. Polaiah, working as a professor in the Department of CSE, Data Science. So it's a great pleasure to continue my video lecture. Today I am going to be continue from our syllabus, that is image processing and analysis subject. Okay. So the name of the topic is elements of visual perception of an image processing system. As we know, such a elements which we are going to be concentrate in terms of visual perception of an image processing system, 100% obviously we are going to concentrate here in detail by the help of certain agenda. So my today topic which I am going to be covered is follows with this sequence of agenda only. So the sequence of agenda, first one is topic introduction, second one is course outcomes mapped with the modules, and the third one is elements of visual perception in digital image processing system, and the topic which we are always where we are going to be understood this learning outcome towards to understand the list of applications also. That's what here the fourth one is list of application image processing is also connected to our today topic. So coming to the here the topic learning outcome where I've been formulated here in terms of name of the topic covered, which I'm starting right now, and how we are going to achieve that learning outcome. And if we achieve that learning outcome, automatically we understand that our course outcome is achieved. So the element here, the name of the topic, which again we are going to learn in terms of elements of visual perception of an image processing system. So elements of an image processing system is different, where we are concentrating now elements of visual perception. Okay, so we'll see the digital image fundamentals based, this visual perception based we are going to concentrate. That means as we understood earlier discussion, obviously it is under the digital image fundamentals only, but now the digital image fundamentals which we are going to discuss in detail as one of the topic is first one, that is elements of visual perception. Of course we are going to be see remaining also later on. You see here the elements of visual perception, basically obviously we are going to follow with certain references book only. So that is what I've been cited here. So the elements of visual perception, how can we introduce as a topic, based on the human visual system only, HVS. As we know, we are aware about an image definition. So that means how can we define an image is, and obviously 100% we are depends on the human visual system based only. We used to define image definition. So that's what this human visual system is right now help us to define elements of visual perception also. So that means the human visual system means a true measure of image processing quality is how well the image appears to the observer. How well image appears to the observer. So that is what we wanted to concentrate here. So and the HVS means human visual system is very complex and is not understood well in the complete scene. So that means you are going to be see that understanding in terms of properties can be identified and used to our advantage levels only. So we are going to be understood this in terms of lens in is flexible and its refraction is controlled by its thickness. Its thickness. Okay. So the thickness is controlled by tension of muscles. Okay. So we are going to understand this human visual system where we are going to be concentrate for defining of elements of visual perception is although a digital image processing fields is built on a foundation of mathematical and probabilistic formulas. Human invention and analysis play a central role in the choice of one technique versus another. So, and this choice often is made based on the subjective visual adjustments. So, visual judgments. Okay. So, what we want to understand from here, the human visual system is right now concentrate. Depends upon the technique versus another. That means there is a choice of one technique versus another, and that choice often is made based on the subjective and also visual judgments. So coming to the here, sorry, the extension of this the human visual system is here. We are able to understand in terms of only structure of the human eye. So the human eye is the main element in your visual perception. Okay. So what we want to understand from human eye. So the eye is nearly a sphere with an average diameter of approximately 20 millimeters. So this 20 mm helps us to adjust your diameter value. So three membranes encloses the eye and the cornea and scalar outer cover, the choroid and the retina. So here retina will be connected to these all elements. One is this one and second one, third one and fourth one all together we are going to be understand right now towards to keeping as a structure of human eye. What is that structure of human eye is here. Let me to show you that one first. So this one is the elements of human eye. So what are those? So if you consider that complete structure of eye is here is we are going to be see towards to understand in terms of lens adjustment. So based on this lens adjustment only, we are going to be see we are going to be observed an image. So that means the observation is completely vary in terms of lens variation only. So we can see part by another the elements of visual perception is here is for example, as everyone may know, the eye, how the structure of human eye is constructed physically, one to another components, one to another elements. You see, one is, let me start from a lens, is the part here, Okay, next, scale area. Next, choroid. Next, retina. Next, vitreous human. Next, macula. Next, optic nerve. Next, ciliary body. Next, suspensory ligaments. Next, trabecular meshwork. Next, cornea. Next, aqueous humor, that is watery fluid. Okay. Next, pupil and iris. Okay. So what do you, and also we want to consider here conjunctive. So with the help of this all elements of visual perception, that is your structure of eye helps us. Structure of eye itself says that your elements of visual perception. Okay, so this actually which we wanted to run in terms of your structure of the visual perception. Okay, so that means rods in the eye are much larger, between 75 and to 150 million, and are distributed over the retina space. The rods are not involved in the color vision and are sensitive to low levels of illumination. When the lens of the eye focus an image of the outside world onto a light sensitive membrane in the back of the eye, so called retina, the image is formed. So I'll repeat once again. When the lens of the eye focus an image of the outside world onto light sensitive membrane in the back of the eye called retina, the image is formed. The lens of the eye focuses light on the photoreceptive cells of the retina, which detects the photons of light and responds by producing neural impulses. Okay, so that is what we want to see here, that graphical representation of our discussion. See figure number 2 compared to figure number 1. Figure number 1 is the overall structure of eye. Okay, so that we are keeping into graphical representation of the eye, looking at a palm tree. Point C is the optical center of the lens. Okay, so you see here, you keeping here is the center. C point is here. C point is this. Okay, this point is here. Okay, so this point based, we are going to be adjust your lens. You see here, your lens may going to be adjusted here. Okay, so your 17 mm and going to be keeping, what is this? 17 mm diameter of the lens. So the diameter of the lens is helping us to see your palm tree in terms of graphical representation. So you see here the brightness adaptation and discrimination is here happen in terms of digital images are displayed as a discrete set of intensities. The eye's ability to discriminate black and white at different intensity levels is an important consideration in presenting image processing result only. So figure number 3 is here the range of subjective brightness sensitivity the range of subjective brightness sensation showing the particular adaptation levels. You see the levels are here. This is nothing but which we can see here what we called bring heights. So here you may see this x-axis long of intensity. Okay, so the adjustment is happening here sequentially. It will be changes from in terms of S curve. Okay, so that values here we are going to be defined now in terms of image process. That is important consideration in presenting image processing result only. Okay, so let us you see here the range of light intensity levels to which the human visual system can adapt is of the order 10 to the power of 10 from the scotopic threshold to the glare limit. In a photopic vision, the range is about 10 to the power of 6. The range of light intensity levels to which the human visual system can adapt is enormous. So on the order of 1010, that means from the scotopic threshold value, the experimental evidence indicates that subject to brightness. That means is a logarithmic function. Is a logarithmic function of the light intensity incident on the eye. Incident on the eye. Okay. So that is one of the important which we are concentrating, brightness adjustment. But whereas if you go to the other elements of visual perception, is here focus on distant objects is one of the element. So what is this element? Again, this element also we are depending on lens only we define. That is, lens is relatively flattened, refractive power is minimum. Okay. So next one is focus on near objects. Near object. Lens is thicker. Lens is thicker. In a refractive power is maximum perception. Maximum perception takes place by excitation of perceptors, which transform the radiant energy into electrical impulses that are decoded by the brain. That are decoded by the brain. So your brain is connected to your focus on near objects. So brightness and intensity is also one of the it is also one of the elements of visual perception. Okay. So what we want to understand from here, the dynamic range of light intensity to which eye can adapt is numerous. The brightness is a logarithmic function of light intensity, which we are going to be concentrating in terms of HVS. That is human visual system, which we are going to human visualization. We cannot operate over the entire range simultaneously, but it accomplishes large variations due to brightness adaptations. Okay. So what we want to understand here, the brightness and intensity is the one of the element under the elements of visual perception that we are going to define. The relationship between brightness and intensity is not a simple function. Okay. So if you wanted to connect this simple function to understand, is right now defining in terms of another element of visual perception, that is image sensing and acquisition. What is sensing and acquisition means? Sensor can be developed that is capable of detecting the energy radiated by a band of the EM spectrum. By band of the EM. You can image events in the band. Image is generated by energy of the illuminated source, reflected. So are transmitted through the objects. So the image is generated by energy of the illumination source, reflected or transmitted through object's X-ray. So let us we are going to be see right now the concept which we are discussing is right now going to be connected to the outcome of your today observed topic, today lesson topic. What is that? The application of the digital image processing are here I am keeping in terms of sequence. One is medical image processing, second is quality control system, third one is visualization, and fourth one is law enforcement, and fifth one is artistic effects. Okay. So by using this, list of application, we can concentrate towards to design your visualization perception based element artificially. So where we can, for example, surveillance. So this complete surveillance application is here obviously depends upon your visual perception only. Visual perception only. So depends upon this visual perception, you are going to be updated. You are going to be updated your artificial structure of the eye for the designing particular application image processing only. So like that, for example, you want to see here medical imaging system. Nowadays, the robotics are designed. Okay, so robots are doing the what we call operations for even cancer tissues. It is removed by the robot only. So for that, the robo AI, that robo computer vision process is obviously depends upon the visual perception of image processing. So there we can concentrate the complete list of applications of this medical image processing is depends upon today topic concept only. So I hope you got this importance of our topic, which we are connected here with the help of our listed applications. Okay, right? So coming to the list of references which we are using here, of course, both are important prescribed textbooks only, but most of we are right now followed with digital image processing textbook, that is with the help of our S. Jayaraman only. Okay, so from this first textbook we are mostly we can depend, and little bit concepts also we divided into second textbook. Okay. So now coming to the I wanted to conclude today's topic, which is elements of visual perception. So with this, what we wanted to concentrate, we will completely cover that visual perception process is considered as an element in the digital image processing. So that element which we are going to be concentrated to prepare for the digital image processing applications. Based on that application only, we'll define your requirement. Okay, so that is important here. That is with this, I'm concluding and stopping today our video discussion. And in the coming class, we are going to discuss further and important concept also. Thank you so much for your patient listeners. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.